All right. Hello, everybody, and welcome to the stream. Hope everybody is doing well tonight. We are going to pick up where we left off last time, and we are going to continue with our refactoring effort. I know it's been quite a lot. We still have quite a bit to do, but it's going to make expanding the engine that much easier once things are sort of organized, right? Built up a lot of tech debt, now it's time to pay some of that off. So, all right. RCW with a watch streak. Appreciate that. How you doing? Good to see you. Brownhounds, good to see you too. Hello, welcome. All right, so before we jump into the stream, I do want to take just a quick second and thank the supporters of the channel, starting with the partners who are the highest tier of subscription over on YouTube memberships and Patreon. I would also like to thank all the other folks listed under the supporters section here who are the other tiers of support on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. I greatly appreciate it. And of course, this project would be nothing without all the viewers here on the YouTube side or on the Twitch side. Of course, you guys support me in the most important way possible, and I really appreciate that as well. So thank you very much for that. Brownhounds, thank you for the Tier 1 subscription. I really appreciate that support. Thank you very much. It means a lot. Okay, so where we were last time is just to sort of give a synopsis of where we are on all of this. We are currently working towards what we're going to call our 0.7 release, which is essentially, it's a bit of a refactor release, but it's also, we're adding and standardizing some things, right? So up to now, our renderer backend, our Vulkan renderer backend, has been a plugin, and it was sort of designed that way from the start. And then our audio system is also a plugin, and then our UI system is also a plugin. But they all had sort of different entry points. They were all organized a little bit differently. And what we're doing is we are standardizing the way that those plugins interface with the engine through a standardized series of hooks, things like that. And then I'm also taking that opportunity to take care of a lot of the sort of technical debt that we've accrued in the engine along the way. There's lots of things that we were sort of like, well, we'll not handle this now. We'll sort of put that off till later, and we'll come back to it, right? Lots of to-dos, lots of fix-me's. And some of those things accrued because we are trying different things on the stream, right? So one of the purposes of this project is it's to serve as an educational resource, right? And so if I had everything sort of pre-planned and pre-coded 100% up front, I don't feel like that's necessarily the best educational value, right? We want to try different things. We want to experiment with different things. And naturally, when you do that, you have some successes and you have some failures and some things that don't work and things that need to be improved. We've outright had some features that we've added to the engine where we're like, you know what, this didn't work out quite like I thought. Let's go ahead and remove it and replace it with something better. Render graphs being an example of that, replaced an old view system that we had, right? So, you know, through doing this, and the fact that this started off as sort of a tutorial series and morphed into live development, you know, a lot of things were initially done to sort of meet that tutorial format, and now we're sort of, you know, paying that bill, as it were. So rather than continue with it as is and try to work around these issues, we're going to standardize things, do a little bit of cleanup, and make things a lot easier and nicer to use, and more stable as well, right? Because we are nearing the point where we're going to create our first game with it, and we need it to be pretty stable, right? So we have to start battening down the hatches, as it were. So with all that said, that's just kind of where we are at the moment, right? I hope all that makes sense. All right, cool. So I didn't get a chance to do a whole heck of a lot offline between the last stream and this one, namely because, you know, time, right? But one thing that I did start doing is I've refactored the way that the texture system calls out to the renderer. So the texture system now calls this, this create texture, right? And this fills out sort of a standard list of options within the texture. And then eventually, it reaches out, and depending on the texture type, will actually do some various things, right? So it'll actually create and upload the texture automatically for cube maps. Depending on some other things, we've got this load texture here, which if we go to that, this guy will actually kind of do all of that stuff through a job, right? So that's multi-threaded, so we're kind of working our way through that as well. And so we're just basically doing, a debug build, and we're resolving these issues as we come to them. And one of the main things that we've been working on is transitioning the idea of texture internal data completely to the renderer backend. And what I mean by that, just as a really quick recap, is for certain texture resources, we need a certain amount of those per what we call per frame, right? So for triple buffering, we need more than one image to back that thing up. But the only thing that really should know about that is the Vulkan renderer, right? The renderer front end doesn't need to know about it. The rest of the engine certainly shouldn't know about it, right? And so all of that stuff should really be tossed off towards the back end, and it wasn't, right? A lot of that stuff leaked out into the rest of the engine. So we're getting rid of all of that stuff. We're properly handling it in the renderer backend, and we are completely abstracting that stuff away from the front end. And so basically all the front end is going to have is it's going to have a handle to that backend resource, and then it's up to the backend to do whatever it needs to create and manage the resources that it needs in order to actually use and upload texture and so forth to the GPU. So that's kind of what we're in the middle of now. Okay, so with that, we've been changing stuff. So obviously we've got a series of errors here, for things that don't exist anymore. So for example, we have in our texture system 656. Oops, 656. This renderer texture create, right? And renderer texture create used to actually do two things, and it's kind of been reduced to a single thing. So getting a texture set up is now a two-step process. Well, it should have been, right? So we have the initial acquisition of resources. So that's allocating the GPU memory for the texture, and in Vulkan's case, the actual Vulkan image and the Vulkan view of the image. For something like GL, that'll be a little bit different. For DirectX, that'll be different. But regardless, we have that process, right? And then we also have the process of uploading the texture data, right? And this render texture create before was sort of combining those two steps, and we really shouldn't have been doing that. And it kind of led to this sort of branchy code that we had all over the place to kind of do that. And this way we can actually just have, textures that are created but don't necessarily have any data loaded to them, because maybe there's a render pass that draws to it instead of just having, image data, pixel data, like raw pixel data thrown at it, things like that. So we're basically replacing this one step with the two steps there. So let's see. So in this case, we're creating a new temporary texture, right? This is after the job has succeeded. The job, incidentally, for the texture system, what the job does is on a separate thread, it loads the image asset off disk and gets the RGBA pixel data, and that's what this pixels is here. And so that has been jobified. That happens on a separate thread, and then this function is the callback that's made once that job is complete. We pass that data over. And at that point, we can upload that to the GPU. We might eventually multi-thread this portion of it as well, but for right now, we don't really need to do that. So, what we need to do here says, in fact, this comment says acquire internal texture resources and upload to GPU. So what we really need here is renderer texture resources acquire, right? And this is sort of the new way of doing things. And so we have the state pointer has the renderer system state. It's got a pointer to that. The texture type, right? So I think we can actually pull most of this stuff actually from the texture params. And then we have temp texture, right, which is our new texture. So we can say type. Right, and I'm actually I'm probably gonna have to multi-line this so that we can see what the heck's going on here. Oops. So we'll do this, and so the width is gonna be, let's see. So at this point, I believe, let me make sure that all of these texture load job start is what we're going to want to look at. We've actually got, what's down here? Okay. Let's see. So we have the temp texture params being set here. So we have width, height, channel count, MIP levels. And then let's see, we have image resource data. Okay, so that's the actual resource off disk being loaded. Do we have? Yeah, so there's going to be some stuff in here that needs to be changed as well. Just leave myself a note there. We'll have to come back to that. Let's see. So we copy over the width, height, channel count, and MIP levels. Do we say anywhere what type of texture this is? Does not look like we do. So I'm guessing we're just defaulting to texture 2D here. Right, so we should probably go ahead and set that. So let's do load params, temp texture, type equals texture type 2D. You have to drop, Bet is calling you. Have a good one. All right, yeah, that's fair enough. I appreciate you hopping in, and I appreciate the support. Have a good one. We'll see you on the next stream. All right, I think this is probably all that we need to do. I would like to maybe simplify this a little bit if we can, actually. Because like we've got this temp texture, and then we've got this out texture thing. Which is making me wonder if we actually really do need both. I think the reason that we're doing that is because the out texture is the old texture that we unload. Yeah, okay, that's why. So it's been a bit since I've looked at this code, so I'm just having to refresh my memory here. So the way that this works is when we load up a texture, we kick off a job. That job getting kicked off is essentially calling this function. This loads the resource off disk. This is how we attempt to get the pixel data from that. We use a temporary texture to load that data into. And the reason that we do that is because this operation can fail, right? So if this texture load fails for some reason, then we want to have a way to roll back. We don't necessarily want to nuke the old texture before the new texture is actually ready to go. And the other reason we do that is because we can actually swap out what texture is being used on the fly, even in the middle of like a frame being rendered, right? So if we hit that situation, we don't want to have to potentially hit a situation where that texture is undefined for like a small brief amount of time. We want to just say, okay, the new texture is loaded. Take a copy of the old one, put that off to the side, immediately reassign the new texture to the old texture's handle, and then delete the old texture, right? You figured out go-to implementation. To get it to work, you actually have to do the compile commands JSON. Really, you can't do it with... That is interesting, Diamond. So you actually have to do it with compile commands. Okay. Does that... Now, I assume you're using C++ for that, right? Or does that work for C too? Because, like, what is implementation in C other than, header versus source file? No, you're writing C, and it works in there. Interesting. Okay. I'll have to look into that then. Are you able to use compile commands JSON as a replacement for... You need to compile with bear or CMake for your compile commands JSON. Yeah, I'm not going to switch to CMake. Not happening. Nope. That's a big bag of nope for me. Just for the compile commands? You mean to, like, generate it? Is that what you mean? Because, like, in my case, my, yeah, just as a secondary script. Yeah, I mean... So, I actually generate, my compile flags file. I generate that using the make file, believe it or not. Because I'm able to just extract the data that we already have, or pieces of data that we already have. So, yeah, I'm thinking I could probably just do it with a make file. I should look into that, though. Because that might make my life a little easier with this. Okay, so... We have, I think, most of the important bits that we need. So we have the type. We really don't care about ID. That's not really being used at the moment. We're going to use that. Width height channel count is being set. MIPS array size. Array size is not being set. Okay, so that might be... I wonder if we're defaulting to 1 on that somewhere. We might be. We must be, I would assume. So this is just for a regular texture load, right? So I think I'm going to go ahead and just do load params, temp texture, and we'll do array size equals 1, just to make sure that we have everything we need. And then we do a transparency check just to see if the texture has any transparency whatsoever. And then we do, instead of an end copy, one other change that we made is texture.name is no longer just like a flat array. We actually have, we dynamically allocate this now. So what we actually have to do here is set that equal to string duplicate load params resource name, right? That way we don't have to worry about the life cycle of that. Max, good to see you. How are you doing? Hope all is well. A C Vulkan Game Engine. What is this madness? You're right, it is madness, but I love it. Yep, we are writing a complete game engine from scratch using C and Vulkan. And in fact, if you're interested in the details of that, did my mouse just die? No. Okay, there we go. There's the kohiengine.com website that's got all the details on it. Render Goblin. The name sounds vaguely familiar, but I think it's been a bit, hasn't it? I feel like it's been a while. I do remember the name. 2 weeks? Okay. Yeah, in my brain, that might as well be 2 years. So the thing is, I have the memory span of a gnat. So... Yes, I do remember you now. Yes, Medusa Frontier. Yes, I do remember that. Yep. Okay. I just wasn't connecting the dots there. How are you doing? So, what we need to do here is I'm just going to make like a convenience pointer to this guy. Right, because that's going to get really annoying to type over and over again. You don't remember the goblin, but you do remember the game. I guess you're doing something right. That's fair enough. I mean, the problem with the name Goblin is like anytime I think about goblins now, I think of Thor's chat, Pirate Software's chat. So that's it. Like automatically associates in my head is the problem. Let's see. Do you also code in game dev field in your day job? I used to. I no longer do. No, I did for 5 years though. A few years back. Liminox, hello. How far are you in your engine? So we have, in fact, I'll just kind of show you what the current to-do list looks like, right? So let me open it. Let me actually open it over here. All right, so this is sort of the file that I use to keep track of things I need to do, things I've already done, stuff like that. And I'm going to scroll through this really quickly because it'll give you kind of an idea of what we've done versus what we haven't. We've got a lot of the basic stuff out of the way, like we already have our renderer set up. We already can load meshes and load scenes, and we've got a scene hierarchy and all that good stuff, right? And all the things that support that. So we have everything here that's got an X on it is done. Everything that is blank is not done, right? And so we've already got a decent list of things, right? And again, I'm not going to like take a time to go through this list because it's a long list, right? And what we're actually in the middle of right now is this 0.7 refactor, right? Which actually I've got a lot of notes in here about it. I'm already planning for 0.8, which is going to be the next release. We've got some render items here that we need to take care of. There's a lot of stuff in here that's already done, right? So we already experimented with a Phong lighting model and removed that in favor of PBR, for example. We have a number of plugins that are done or in progress. We have a UI system that we started sort of building out, a custom UI system. Obviously, the editor is a to-do, right? Until we actually get the runtime executable like nailed down, we don't want to build an editor on top of it just yet. And then we've got some other items here, right? So it's like 300 line items of stuff, more or less. You haven't heard of any goblins on Thor's chat? So Thor is, if you're not aware of who he is, he's Pirate Software on on here, and he refers to his chat as goblins. That's just kind of, I think he says as a group of goblins is a chat. Yeah, okay, yeah. So that's what I meant about that. Yeah. Sounds about right. Yeah, it's pretty accurate. Pretty accurate indeed. All right. So yeah, that's more or less, kind of where we are. If you actually pull up the website itself, we have, an entire thing built out here, where you can get, frequently asked questions, API documentation if you want it. There is a Discord server available as well. Links to the YouTube, Twitch channel, all that stuff. The GitHub repo, which is here. So the main branch has version 0.6 merged onto it because that's the latest release, so to speak. But we also have a 0.7 that we're working on right now. This is a screenshot or a couple of screenshots that are a little bit aged at this point, but they kind of show where we're at in terms of rendering, and a little bit of information about the engine. So, frequently asked, yeah. I probably need to update that because I haven't touched it in quite a while. But, that's basically that. All right, so Restless Ambitions, thank you for the follow. Appreciate that. Welcome. So, now we're kind of in the middle of a big refactor / taking care of a lot of tech debt that we have accrued over the lifespan of the project, right? So that's what we're doing tonight. Apotham, good to see you. Smudge, good to see you as well. Welcome, guys. How long have you been in development on this? We just passed 3 years. But bear in mind, I am doing this part-time, right? So I only stream generally 2 nights a week, and I work on this in my spare time. I do have a full-time job. That's not this. So yes, I've been working on it 3 years, but if you were to compress the amount of time that I've put into it into like normal working hours, it's probably more like 6 to 8 months, realistically. Sergeant Pepper, how's it going? Good to see you. Yeah, no. I get your point, Render. Yeah. Just to, kind of put it into perspective, because a lot of people, they hear 3 years and they're like, oh, wow, why isn't it done yet? And I'm like, well, I'm one guy, dude. I'm one guy working on it in my spare time. So that is, it is what it is. If I could work on it full time, obviously we'd be moving a lot faster, but that's just not the way it works sometimes. We are going to have ads shortly. So I'll go ahead and point this out now before we actually get into that. Is one thing that I like to do on this channel so that nobody misses content is on the Twitch side, we are served ads once every 30 minutes for up to 90 seconds. That amount of time varies based on region and locale. But the bottom line is I don't want anybody to miss content because that sucks if you're watching a programming stream and you're kind of following along what's going on, and then a full screen ad comes up and gets in your face and you can't see or hear anything, right? Some people don't see ads, a lot of people do. So to even the playing field, I pause the stream whenever ads come up, so that we don't have that issue, right? You're from Nepal. That's pretty cool. That's a long way away. Well, welcome. No Twitch ads there. I suppose that's a good thing, right? Let's see. Going well, good, okay. In 2 years in early access on my game, and like, oh my god, IRL, sidelines, taking a break from it, yeah, reality, yep, 100%. Yeah, I get you. Reality sneaks up on you quick. Responsibility and adulting, right? I remember you used Rust before. Nope, that's not me. I tried Rust once a while back and was not a fan. To be fair, I didn't give it a really long or fair shot, but yeah, I like having control over my memory. That's just how I kind of roll, you know. Rambo Mad Cow, thank you for the follow. All right, and we have ads, so we're just gonna break. You're aging, yeah. I feel that. I feel that every time I get up in the morning and something new hurts. Wait, you're 19 and a quarter of the way? Is your project a public repo? Yes, it is. Yeah, so it is at, the easiest way to get there is to go to kohiengine.com. And on this page, if I can get it to stop trying to extend the whole screen, as soon as the ad break is over, I could show you this, but as soon as you open that page, if you scroll down, there's a link to GitHub on there. Rust rewrite coming up. No, not for me anyway. Dr. Vexy, thank you for the follow. Appreciate that. For you, yeah. Fair enough. Almost done with ads, by the way. We got about 5 seconds left. What better way to learn Rust and Game Engine Dev? Yeah, so I was actually, funny enough, I was thinking of doing something similar to try out Zig and to try out Odin, because those two languages kind of interest me a little bit, and I want to try them. I'm leaning more towards Odin these days than Zig, but I suppose I could do it in Rust if I really hate myself. But I don't know. Game Engine is somewhere where I like having complete control over my memory, so. Yeah, RCW, that's the same thing that I like having complete control over my memory. I don't like it being taken away or the compiler slapping me and being like, you don't know what you're doing, noob. I don't like that. Not a fan. But yeah, to answer your question about where the repo is, it's just github.com/travisroman/kohi is there. If you head to kohiengine.com and you scroll down from the top, there is a link right here, right? And also the open source thing here is also a link to that. So yeah, it's I should point out it's open source, it's free. There is no licensing of any kind, ever. There never will be. In fact, let me actually just pull that up again. Right, so if we go to GitHub, it is Apache 2.0 licensed. So what that means is basically if you use it, you just have to say you used it. It's free for use for independent or commercial, right? There's no royalties, there's no licensing fees of any kind ever. This will always be 100% open source and free. You did the first 30 episodes of this series in Odin and you enjoyed it. That's kind of awesome. That makes me want to try it, right? You're a web dev, you appreciate the guardrails. I mean, yeah, I do web dev, during the day. I still get annoyed by the guardrails in web dev. Guardrails are nice in the right domain. Just a control freak. Yeah, I'm a control freak too. Like if I could write server-side code in C, I'd probably do it. Math and Vulkan support out of the box is cool. Yeah, that is pretty neat. Yeah, that is one of the things that has me looking at Odin pretty hard. If I was able to do this stuff full time, I'd probably just make a language of my own, but I don't have 8 years to make another Jai. You write C in your day job is pretty satisfying. Yeah, I would if I could, but the job I have pays the bills, right? So can't complain about that. Okay, so this is texture. And we're just going to take a convenience pointer to that. I think I can just call it T. That way, I can stop doing this rubbish and just do that rubbish. Right, so T type, T height, channel counts, map levels, array size, flags, and then we have a handle here. So actually, I think we can actually do the address of render texture handle. Okay. And so this returns a Boolean, so we need to check that to make sure it was successful. And if it was not successful, then we need to bleat about it. Let's say error requiring renderer backing resources for texture in return. Right? And then as the second step in that process, we need to say renderer texture write data. And so this is going to be state pointer renderer. And the handle here is going to be T renderer texture handle. The offset in this case is going to be 0. The size, I think we have, do we have the size still? The size is basically going to be, I already calculated this down here somewhere. I shouldn't have to, yeah, right here. So we could take the size and put it here. And so this is going to be right? T channel count. So we have width, height, and channel count, right? That's going to give us our pixel size. And so we can say total size, right? And then the pixel data is going to be the resource data. Pixels. Right? And so we can get rid of that. And now we have loaded our textures, sort of the new way to do it. So I'm actually going to do that just so that the comment isn't misleading. And then upload pixel data to GPU. Whoops. And then I'm also going to do a check against this to make sure it's successful. And if not, then we're going to say error uploading pixel data to GPU for texture. We should probably always do this, actually. T name. Right, so we should probably do that here too. T name. Right. Let's see. Jumped over to Twitch from YouTube. Been a long time watcher supporter. Just want to say thank you. Have learned a ton watching you work on this. Great job. Thank you. I appreciate that. Oh yeah, it does look like I have a couple of things to check on over on the YouTube side. So I will get to those in just a second. Grim Heartless, been smirking seeing your average views being over 15 people. So sick. Awesome. I appreciate that. Appreciate that a lot. Over in the YouTube side, Terry Davis Media. How's it going? Most people don't know you can bypass X with DRI to directly write to the frame buffer by exporting dev FBO, dev FB1. This is in Linux. That does make sense, actually, now thinking about it. I love that Linux affords you the ability to do that kind of stuff, you know? I wouldn't want to rely on it per se, but that's kind of awesome. I could probably use that for debugging purposes. Oh, Mike, I think you were the one that hopped over to YouTube, but thank you. I appreciate that. Funny how people will compare a solo dev's engine to a massive team effort like Unreal. The amount of times that's happened is actually shocking, Max. I've straight up had people ask me like, well, so when are you going to add like Nanite? And, you know, how does this compare to Unreal? And I'm like, dude, I'm one guy. I can't compete with Unreal. They've got dozens of devs working on that engine, you know? Singy, how's it going? Good to see you. When's there going to be an asset shop like Unity? Does not even have Nanite. I'm out of here. I thought this was an engine of some class. We don't use classes here, though, Diamond. That's C++. We have no class here. Can't even compete with Unreal. It's time to boycott. Yeah, it is what it is. Skill issue. Skill issue. Classless engine, but just the way we like it. Exactly. Yeah. Damn, I wish I could have actually called it that. Missed opportunity. Virtualized geometry engine isn't impossible to do, but the mesh cluster hierarchy generation is trickier. Yes, that's where the trickiness of it. And, you know, if that was the only thing I had to focus on, then yeah, sure. But, like, that's just one tiny part of a very large engine. Time to reverse engineer Nanite and call it something else to avoid probably the lawsuit. Call it Marmite. Marmite. That's awesome. There's massive value in the licensing, or lack thereof. Yeah, that's true. But Unreal can do it. Someone who's never written an engine. Yeah. Vegemite. Vegemite. That's pretty popular in Australia, from what I understand. Yeah, I think, you know... did I put that on my page? Yeah, I think I even literally put that on the front of, let's see. You know, like, be warned, it's not for the faint of heart. But I think I also put in here that it's not, like, meant to compete. Yeah, it'll never compete with the likes of AAA engines, nor is it meant to. I literally put that on the front page. Popular, still gross. It's like spreadable salt. Ugh. That sounds terrible. Rating game engines is pure pain. I don't know why people even do it. I literally know over 10 people on Twitch who are doing it. Yeah, it's very rewarding, though. Like, once you actually get stuff working, it's super rewarding. It's like the liquid nutritional yeast. Okay, I do know what you're talking about there, because my wife eats that stuff, and I can't stand the smell of it. But, yeah, I do know what you mean, though. She likes it, but I don't know. I can't do it. I've tried it, but I can't do it. It's actually nice on some toast. I'll take your word for it. I'll take your word for it. You just had your gag reflex triggered. That's me with olives, actually. AAA teams literally have engineers, mathematicians designing custom algorithms. I wouldn't want to try to compete with that. Yeah, exactly. Like, I can't, you know. I can't compete with that, for sure. Oh, you hate olives as well? All right, cool. We're in the same camp. All right. So, destroy the old texture. So, this, I think... that doesn't exist anymore. I think we don't have the renderer destroy texture anymore. We have renderer, resources release. Right, so we have state pointer, renderer, and now all we have to do is pass the handle from the texture. So now we can just say old handle, right? And that's it. No more passing pointers back and forth. All right, so we zero the memory of the old texture, and then unload the resource, which is the image resource. That could be done a lot earlier. That should be done a lot earlier. Like as soon as this happens, right? We can unload the resource there. And theoretically, like, we could even unload it sooner than that if we take a copy of the pixel data. But that involves another copy operation, which I don't feel is completely necessary. So we can unload the resource there. I don't think any of this other stuff is going to have to change. I think we'll be fine with the other things here. Okay, so successfully loaded texture. Okay. Actually, this is kind of unnecessary too, because this just becomes a... This is just a local variable. We don't even need to do this. That can go away. All right, and I don't think this returns a Boolean because it's a release. Yeah, okay. So we should be good with that, actually. Yeah, olives are kind of slimy. Yeah, I agree. Fully agree. I get it. I'm the weird one that likes both black and green olives. Jalapeno and garlic stuffed ones are great. Yeah. My wife loves the hell out of olives, and I just can't. Like, thankfully, she's really good about it. Like, she'll stay away from me with them because, like, they're one of the foods I deplore to the point where, like, if I even catch a really strong whiff of it, it'll turn my stomach. But thankfully, she's really good about that. She doesn't, like, jokingly, like, try to feed it to me or anything like that. She's really good about it. She's the best. All right. So we have that done. Let's see what other build issues we have. Error numbers are dwindling. Okay, so we've got a couple of these render texture creates and destroys around here still. So it looks like 745 is the next one we need to take care of. All right, so, oh, this is for a layered texture job. So this was another thing that I was thinking at some point we should probably combine, is layered textures and single layer textures, but I'm not going to do that now because the scope of this is already big enough, right? But what I can do is there's no reason to do all this stuff like from scratch again. So let's just take that whole section and we'll just basically do an insert here. All right. And so typed result data block. Typed result temp texture. Okay, so this is a little bit different. Typed result temp texture. I think the way we structured this job is a little bit different. Typed result data block. What is data block is the pixel data. Okay. So that needs to be over here. Typed result data block. Right, and actually, I think we did handle the resource differently here, so I don't think we actually need to handle that. Here, I think this is an example of what I was talking about. We take a copy of the pixel data and then throw the resource out. So I don't think we need to handle that. Oh, Kuju, how's it going? Thank you for the raid of 19 viewers. Appreciate that. Yeah, I was watching you earlier, and it's pretty. I'm liking what I'm seeing of Jai. I think, like, part of me wants to give it a shot. You know. But let me give you a shout out real quick. So if you are not, wait a minute. There we go. There we go. If you're not following Kuju, you should be, because they are doing game dev using Jai, and the game that they're building is looking really great. So I highly suggest you give them a follow, check out their Steam page, and wishlist the game if it interests you. Okay, let me check out. So how's the stream going? It's going pretty good. We're in the middle of a refactor effort. So basically, we've been working on this custom game engine for about 3 years now, part-time. But it started sort of as a tutorial format because this is like meant to be sort of an educational resource. And so a lot of the decisions that we made between that and all the experimentation we've done has built up some tech debt. So we're kind of taking care of that now. We're refactoring some things. We're standardizing our plugin system. So our engine architecture is actually mostly based around plugins, where the renderer itself, or at least the renderer backend, is a plugin. So the Vulkan renderer specifically is a plugin. And then, you know, a Direct 3D renderer will be a different plugin if you want to use that. And then we'll eventually have one for Metal as well for native macOS support, because right now we're getting that through Vulkan, but through Molten VK. But yeah, we're basically standardizing our plugin system, working out a lot of long-standing issues in our renderer, and just kind of battening down the hatches, cleaning things up so that we can start making our first game with it sometime soon. So that's kind of what we're working on at the moment. You just haven't had the right olive with the right pairing. No, there is no right olive for me. Appreciate the shout out. Yeah, no problem. I appreciate the raid. Thank you for that. Definitely worth it. Jai is great. Yeah, so the only thing that concerns me about Jai, and this, you were actually talking about this a little bit on your stream earlier, was like if, like, he owns the language, right? So like if he wanted to ban you from the language, theoretically he could do that if the licensing allows for that. So, like, I don't know that I would ever want to switch to it unless it went open source. You know, with a permissive license. That would be the only thing stopping me, because I would not want to wind up in a situation where I have, like, lots of work under that, and then, like, I'm not saying he's going to pull a Unity or something, right? But, like, it could happen, right? Or something happens, you know? And then that license changes, and then what, you know? So that's the only thing that concerns me a little bit about it. But it's a pretty nice modular way of handling the complexity. Yeah. So that was a decision that I kind of pivoted to early on in the design. My initial design didn't account for that, but I kind of wrote it in a way where it was very easy for me to say, okay, well, actually, I have this renderer front end and renderer back end system where the front end is sort of what communicates with the rest of the engine, whereas the back end is where all the API-specific code lives, so Vulkan code, not. And it was very easy because of that split that I already had to just pick that up and make a plugin out of it. How do you separate the game from the platform code? So there's a couple of answers to that, right? There's a couple bits, I should say. So the way that the engine is organized, right, is we have this sort of core library that contains a lot of our custom types. It contains some of our things like memory, our math, some of our debug type, like low-level stuff, our logger, string library, time utilities, containers like dynamic arrays, hash tables, that kind of thing. But it also includes the platform layer, at least for right now. I may split this out further. So the platform layer in our case is the abstraction layer between the engine and the OS that it's running on, right? So we have one for Win32, we have one for Mac OS, and then we have one for Linux, which right now is technically X11. We're eventually going to have one for Wayland too, so there's actually going to be a split there. And then eventually we're also going to have Android and iOS on that list as well. And, you know, and doing it this way, essentially, if we wanted to add something like Xbox or something like that, we could do that as well. And so right now, each one of these is essentially include guarded, right? And if deft, right? So, you know, since we're on Linux right now, this is the one that's actually going to compile. If I opened up Win32 platform, you'll notice it's kind of if deft out, right? And so that's how we do it at the moment. I've considered also turning these platform layers into plugins themselves, so that they can just compile and just kind of sit along with it, and we don't have to worry about platform that much. And then when you download a build, you just have the libraries that you would need, right? So I don't know how that's going to work out. I haven't tried it yet. But back to the main question. So we have this sort of core library where all that kind of stuff lives. And then we have the runtime library, which is where all of our sort of engine-specific stuff lives, right? So that's our application loop, our renderer front end, our things like our render graphs, some of our core functionality like our console, our engine itself, right? The event system, input, key maps, our KVAR system, metrics, systems manager, which that's actually going away. Our audio front end lives in there as well. And then a bunch of our various systems like our camera system, our font system. We have all these various systems, right? These subsystems. And so that's kind of where that lives, right? And so the idea behind splitting these two up is the runtime is basically what any application that uses Kohi would want to use. And when I say application, I mean anything from a game to like an editor, right? So our editor is going to be a freestanding application separate from our game, for example, right? But both of those would consume the runtime library, right? So the runtime links back to the core, right? But the core library is here because we're also going to have utilities that are freestanding separate from the engine runtime, right? And those might be things like our custom build processes, things like that need the types, but don't necessarily need the whole engine, right? So that's our split up there. And then we have our plugins, which is, you know, our audio plugin, which in this case our only audio plugin is OpenAL based. We have our renderer plugin, which is our Vulkan plugin. And then we have our standard UI plugin, which is sort of one of many UI systems that we're going to put in place. And then we have a small like runtime tests library. And then we have tools, and then we have something called version gen, which is an example of a tool that's freestanding that uses the engine core. And it just generates a version number for us every time we build, right? And then our actual application is split into two parts as well. So we have right now we have what we call our test bed, which is basically our application that we just kind of throw code into to test engine features. And so that is just typically named with the K app for Kohi app, right? And that's our executable. And so the executable is very light. All it basically does is it contains a configuration for some basic engine configuration, as well as some configuration behind what plugins we're going to use and how those plugins should be configured. And then we also have the testbed klib, which is the library of code that is associated with that application, right? So these things are named the same thing. These are one application, right? This is the executable. This is the library of code that goes with that. And the idea behind the separation here is that the testbed library code is hot reloadable, right? So essentially what that means is we can recompile this guy on the fly while the application is running and get that code update, right? So that is basically how we have that architected. And now we have ads. What timing? So for those of you who are new to the channel and can still hear me talking, we like to pause the stream whenever ads come up on the Twitch side, which is once every 30 minutes for 90 seconds. And I do that so that nobody misses any content. I'll repeat this once we come back out of ads so that you guys can understand that in case you're not able to hear me. All right. So we'll just give our ads a minute to run through. We've got about 50 seconds left on ads. If you can still hear me, hydrate. Let's see. Yeah, I agree, Max. Like, I'm never one to hop around to the latest language fads either. But yeah, Jai is one that I would like to give a decent shot for sure. Zig, I think, is going to suffer from just being too new. Right? It's not quite run its paces yet, I think. All right. And ads are dead. All right, cool. So, the ads kind of snuck up on us there, but for those of you who are new to the stream, what we like to do is we like to, whenever ads are served on Twitch, which is once every 30 minutes for up to 90 seconds, I like to pause the stream so that nobody misses any content, right? Because nothing sucks more than having some full screen explanation going on with some code going through things, and then bam, there's an ad screen that comes up. You can't see or hear anything that's going on, right? So I pause the stream so that nobody misses anything, and I usually encourage people to, you know, get up and get something to drink or something during that time. That's why I put a timer on the screen, right? So you know exactly when we're coming back. Okay. So let me just, let's see. Eventually compiling kohi for ARM excites me greatly. So technically it already does run on ARM if you count a MacBook Pro, right? Like, that's actually what I'm streaming from right now, but kohi runs on that. Granted, through emulation, but still. Eventually, that will be a target as well. My engine is called Fracture, and my apps will be called F-app. What have I done? That's good, Diamond. I like that one. Let's see. I don't get the ad alerts when I stream, and it's annoying, so I never know when ads are running while I'm streaming. It's like a stream layout thing in the stream manager. If you have the stream manager up, it tells you. Speaking of Zig, they actually seem to have a C port of the Jolt physics engine, which is interesting. Ooh. So, yeah, that is one thing we're going to need to tackle at some point, too, is a physics engine. Oh, you hadn't considered that. Yeah. So technically it already runs on ARM. Technically. Because we build on that platform. SIMD should be interesting to see how that works. All right. So, I think I pretty much covered everything in terms of how the engine is organized. I hope that all that makes sense. I'm all for Scratch, but I ain't writing a physics engine. Yeah. So that is probably where we're going to break the rule a little bit, right? Is a physics engine. We might write something like super high level just to kind of like dip our feet into that territory. But like writing a full physics engine can take a couple of years by itself, right? And I'm not sure that I want to do that. So I think probably just like a lot of other things, we're going to have a plugin for the physics engine so that you can run multiple ones. And we'll just set it up that way, right? Have you done SimD and Kohi yet? Nope, I have not. We have to cover that at some point, actually. But yeah. Yeah, so when we do physics, we are going to implement that as a plugin, right? And we'll have a physics plugin. Which, incidentally, part of the reason that we're doing that plugin stuff, by the way, is one of the things that grants us is we have this kohi plugin renderer Vulkan, right? But we could also have a headless renderer plugin that we use for like unit tests and integration tests and stuff like that, right? Where we're testing things that aren't necessarily render specific and we don't care about that. And so we can actually write another plugin for this that we can use in testing scenarios that just runs and executes code but doesn't necessarily have to start up the render and all that. So it could just sit somewhere on some server and run and execute unit tests and that kind of thing, right? And integration tests without actually having to have a graphics card. Looking forward to the SimD implementation. Yeah, that's probably going to be done after the first game we ship. You've written a physics game engine, can confirm the timeline. Yeah, I believe it. First time chat, welcome, by the way. And thank you guys, by the way. I want to say thank you for all the follows. I appreciate all of that. All the follows. Appreciate that very much. Made a bouncing ball in 2D once. How hard could it be? Famous last words. Famous last words, my friend. Okay. So we were in the middle of RPG platform. Thank you for the follow. Appreciate that. Dr. Elliot, first time chat. Hello, how are you? Hope everything's going well. So we're in the middle of basically also making a conversion from an old way of doing things with the renderer to a new way of doing things with the renderer in terms of how we talk about texture uploads and resources and whatnot. The Numbat, thank you for the follow. Appreciate that. Welcome. We are one follower away from 1,500 followers, by the way. That's incredible. I really appreciate that, guys. That's actually a pretty substantial milestone. Oh, thank you guys for the follows. I appreciate that a lot. Now we are over. We are over 1,500 followers. I really appreciate that, guys. Thank you. That really means a lot. This is Kohi. Yep. You watched some of my videos a long time ago. Oh, awesome. Well, welcome. Welcome back, I should say. Hypothetically, what shapes would you want for collision? Any idea of what constraints you'd be interested in as well? So most of what I would do for an engine like this would be a rigid body, and it would probably be, I'm thinking exclusively convex shapes, right? Because concave gets really annoying. But yeah, you know, you probably want to keep it to somewhat basic shapes. Like you'd want to have your basic cone and cylinder and cube and stuff like that, and of course a ball. But you would also want to have the ability to have, you know, specialized geometry as well. Tammin, good to see you. Welcome. Welcome, welcome. You've been learning Vulkan on the side too, and Dear God. Yeah, you know what though? Like, yeah, Diamond Capsule is another one for player movement. Yep. So the good thing about Vulkan is like once you get past the bootstrapping of it and you get past like all the render pipeline stuff and loading up your shaders and all that stuff, like once you get past that point, the amount of Vulkan code that you actually write is fairly minimal, with the exception of ray tracing. But like once you have that core stuff in there, like it's not that much, right? And I realize I say that and my Vulkan backend file alone is 4,000 lines. But bear in mind, some of that is comments, right? But still. Let's see. You finally just made a functor system to be able to quickly add render commands without needing a central render loop. That would be an interesting thing that I am interested in exploring at some point. I've kind of been rethinking my decision to hide command lists from the front end. I'm kind of beginning to like lean towards maybe not doing that, but I haven't really, I haven't decided that I want to pull that trigger yet. I think I'm going to fork Kohi and make a plugin for my physics engine. Do it. Yeah. I'd be interested to see that. Once you get past all the Vulkan code. Yeah, exactly. Following your journey on Vulkan on Cherno's Discord server. Oh, are you like posting your Vulkan progress there? That's pretty cool. Quite a frustrating one. Spent like 4 hours on linker issues last night before I gave up. Yeah. Yeah, when you're trying to learn all that stuff, it gets a little bit annoying for sure. Newest APIs are designed to run command submission. Yeah, and I was trying to sort of get away from doing that. I was trying to be like, well, I don't want the rest of my engine to care. But now I'm like, I don't know that that was a good decision. I don't know that it was a bad one either, to be fair. Vulkan Jai was really nice. Yeah, I believe that. You came from years of UE, took their module and leaker system for granted. You miss it. Yeah, that's fair. Let's see. Over in the YouTube side, Broccoli Rob, hello. Looking at ways to do cross-platform SIMD. Intel's ISPC language is kind of neat. Be cool to dip into SSE or AVX extensions for a bit for SIMD. Yeah, so that's actually my plan, is actually to dip into that stuff exactly. And obviously, I have not done this for ARM at all, so I'll have to look into that separately. So we may wind up having a situation where like we have SIMD for some platforms and not others. Pete's Astrophotography. Wow, it's 2:45 a.m. there in Scotland. Scotland's on my bucket list to visit, actually. But yeah, welcome to the stream. I'm glad you're here. Is there a modular way of switching out segments of architecture in a fire and forget way? Maybe some way of using handles, slots, similar to how UE uses components, just pondering. So, yes, there are ways to do that, but there are certain things you can't do that with, right? Like something as core as the renderer, you're not going to want to do that with. But other systems, yeah, you could absolutely do that. Like our standard UI system is completely disconnected from the engine. Like the engine knows nothing about it, for example. And yeah, speaking of handles / slots, right? Like we're actually switching to using handles for a lot of things over pointers to stuff. So that's another part of this refactor that we're doing. Okay, apparently the bot is still not catching links. Perfect. Worked on a rigid body simulation last year. Implemented oriented bounding boxes versus oriented bounding boxes. Oh, nice. Okay. Bounding spheres. Yeah. I assumed it meant something besides bullshit. It was all fine and dandy until you have multiple objects laying on top of each other and trying to prevent them from intersecting with each other. Yeah, exactly. Or my favorite test case is where you have like two wedges like this, or I guess like this, right? And you enter it at a very high rate of speed. What do? You know? Your renderer is around 1,400 lines of code. Keep in mind, it's very basic. Just renders different 3D models. Don't even have lighting. Yeah. And see, like one thing that we've done is like part of the reason we have so many lines in our case is because a lot of it is descriptor management, right? And like uniforms and stuff like that. Oh, look, Coffee Lava's friend. This weekend, I'm going to look into WASM support because you want to do game jams with your engine. Yeah, that's pretty cool. WASM would be really fun to actually support. You feel behind. I have a few tests and a dainty little window open right now on my engine. Also, a half-baked Vector 2.3 implementation. But never feel behind though, right? Because everybody's got to start from somewhere, right? So like when I started this engine, for example, which now is just over 3 years ago, like if I took a look at Cherno's Hazel, for example, like, yeah, of course I'm way behind on it, right? I'm way behind where he is on progress. But, you know, there's a thing called real life that gets in the way that prevents you from moving forward on that stuff, and that's okay. Everybody works at their own pace, right? The important part is that you're learning and you're moving forward. As long as you're doing that, nothing wrong with it. Work at the pace you need to. Once I started using handles instead of pointers, a whole new world opened up for me. Yep, exactly. And we're converting the whole engine to do that. I wish I had thought of it before I got too far into it, but I only kind of thought of it maybe 6 months ago. It's kind of cool that if you dive into geometric algebra and you use math for physics, you can combine force and torque into one. If I recall correctly, motor mathematical object called fork. And it will generalize in 2D and 3D too, which is very nice. Being able to make stable stacks of things that counts for most of the code in a physics engine. Yeah, that's true. Let's see. That's true. Yeah, Cherno does have a whole team working on Hazel as well. What made you choose C instead of C++? Language simplicity, compilation speed. I don't use OOP, so classes and all that stuff, I don't need any of that. I also don't use templates. I didn't use most of the features of C++, right? Because I programmed in C++ for a long time and then realized that my C++ looked a lot like C. The only thing that I ever really used in C++ was like operator overloads and what did they call it? User-defined. I want to say user-defined constants, but I can't think of the compile time string hashing is basically what I'm getting at. I can't remember the term for it, but those are basically like the only features I used. And I could drop those, and I've been happy with C ever since. Let's see. It's exciting to see so many people and where they're at with their engines. Yeah, I agree. Has anyone here seen Guilherme Terres' engine? I feel like his engine is much more stable than Hazel. What is it called? I don't know that I have seen it. Honestly, I would use C++ only for the data structures. I don't want to be making my own hash map all the time. I mean, yeah, but once you've done it once, right, you could just pick it up from one code base and move it. The Cave engine. I have not heard of that one, but I'm going to look it up. Let's see. Do they have a GitHub? Or is it like closed access? Let's see. This it? Definitely inspired by Unreal. Not that that's a bad thing. Yeah, it looks pretty good. On the surface, anyways. Cool. Let's see. So I'm guessing by this it's Windows only. Which that's a bummer for me because I'm currently on Linux. But I get it. I do get it. Supporting Linux is not for the faint of heart, for sure. Let's see. Yeah, making your own C-based library is like a rite of passage. Exactly. And we've done that here. Yeah, it does look like a very nice engine, though. I'm going to check it out. That's worth booting into Windows just to check that out. You've not used a single STL header yet? Yeah, I found myself not using them either. Unfortunately, it's not open source. Yeah, and that would be like, that's a bummer for sure. You have your own bare bones C-based lib, but it doesn't have a lot right now besides type redefinitions and stuff like that. But yeah, that's the thing though. Like, you have to start from somewhere, right? Like this, I literally recorded creating the GitHub repo. So everybody starts from somewhere. Let's see. Okay, I have some YouTube chats to catch up on. What's the timeline for this engine? So there isn't one, right? We're going to keep adding features to it. One thing we are going to do along the way, though, is we're going to, once we hit certain points, we're going to stop developing the engine, and we're going to use that engine to develop a game and release it. Which obviously will mean that we'll have to tweak the engine a little bit, but we're going to use that as sort of a litmus test for the engine along the way, right? So we're actually getting very close to the point of doing our first game with it. Now we don't have an editor or anything like that yet, so we're gonna build one specifically around the runtime, because the runtime needs to be locked down and solid before we start building anything else around it. So we're going to build a game based off of our runtime here very shortly. It's just going to be a simple game. And then we'll go back to engine dev. We'll add some more features, make it a little bit more robust, and then we'll build another game, and we'll sort of rinse and repeat. And the third game that I have in mind for it is going to be quite complex, so we are going to need an editor for that, and it's going to be quite a longer road to that third point. But yeah, that's more or less the plan for it, right? We don't have specific timelines, simply because this is a side project. It's not what I do for full-time work. So unless, that is able to change, which I don't see how it would, that's kind of where we're at with that. Wouldn't using handles instead of pointers introduce more overhead as the handle usage amps up? Depends on how you do it, right? So in my case, a handle is it's comprised of two parts. So there's a index into some resource array, and each system that hands out handles to things is responsible to link up how that's hooked up. And then there's also a unique identifier within that handle that we use, and we also track in each system to make sure that the handle isn't stale, right? And so, yes, there is an overhead with checking those things on occasion, but you don't always have to run those checks all the time, right? So all it is instead of your level of indirection going through a pointer, right, your level of indirection is indexing into an array, right? So it's still a single level of indirection. It's just a different way around it. Let's see. What's the advantage of handles over pointers? So for one thing, you don't have to worry about null pointers ever. If you have an invalid handle, you can gracefully handle that, right? So you don't ever have to worry about that. You don't have to worry about, well, how many things have a pointer to this object when I destroy it, right? All that happens is the handle just becomes, what we call stale. And then whenever you try to use it, it'll, the system should recognize that handle is stale and move on, right? It should be able to just say, hey, this handle is stale. We can't use this. Move on. Hi, just now tuning in. For your renderer, are you implementing some sort of wrapper in order to support other graphics APIs, or are you just focusing on Vulkan? So yeah, we do have a renderer front end and a renderer back end. So the front end is a API agnostic system that the rest of the engine communicates with. And then we have the back end, which is where all of the renderer API specific code lives, right? And that's actually a plugin as well. So we have a Vulkan plugin now, and it's being designed in a way where we can also have a Direct 3D plugin and a Metal plugin. So yeah, it's being made so that there's a mapping that goes on there. Cherno was a pro developing engine for EA. He's no joke. Yeah, no, he definitely knows what he's doing for sure. Cave engine seems neat. Yep, I agree. Templates are the work of Satan. I agree. Used C++, used to use C++, but reverted back to plain C. It's a much simpler language. I agree, and it compiles so much faster because of it. Pretty sure handle validation only involves one constant time random access into a D array, and two UUID comparison string compare. Yeah, and actually, when I say UUID, in my case, it's just a 64-bit integer that's unique across the system. So it's not even a string comparison there. So it's constant time regardless of how many handles objects you have sitting in memory. Exactly. Yep. Hope to have an example game type such as first-person, third-person, vehicle, open world. Yeah, we'll eventually have all those kind of things, right? We'll eventually have templates, but templates don't really make sense until we get a little bit further down the road, right? Until we have sets of features that can be configured to set those templates up. I suppose it marginally affects CPU processing speed power, which means using handles, which are easier to work with, outweigh using pointers, even at a small amount of loss of power. I mean, theoretically, yeah, but I can guarantee you right now it's never going to be the choke point for FPS, right? Or performance. There's just no way. It's always going to be the renderer or physics. Or, AI if we get into that, like enemy AI. All right. Let's see. I got to back up a little bit because we have a bunch of Twitch comments I got to check up on too. I do kind of have my... Oh, wait, I already read that one. My arena allocator is a linked list of linked lists with fancy memory management. Yeah. That's more or less... So my arena allocator, which I call my dynamic allocator, is really just a huge block of memory with a free list in it. More or less. Do you think you could participate in the next Ludum Dare with Kohi? That is my goal. Now, I don't know, because I know one just passed, right? So the next one is theoretically in, 6 months? So I would like to plan for that and to be able to do it. That's my goal. Depending on where we wind up with the engine, it may be the next one or the one after that. So... yeah, at the end of the year. Yeah. So it depends on where we land up with that. I don't know. I've started thinking about it. I just don't know that the engine is going to be ready for it. Hopefully it is, but let's see. The next thing I want to put in is my own string type. Yeah, so we actually, I do want to put in a string type, like an actual high-level string type as well. Because right now we just do C strings across the board, which is fine, but the editor camera in that engine is awful. It has interpolating movement, and the sensitivity is defaulted to painfully slow. Oof. See, and that's a cool effect, but I feel like a lot of people overdo it. It's configurable, but yeah, if your defaults aren't sane, that's something that should probably be fixed. Also with handles, you can reallocate the resources without having to worry about pointer lifetimes. Yes, that's a big advantage to it, right? It's another huge advantage, for sure. I'd say that handles versus pointers will never be the closest gator to the boat for performance. That is an interesting way of putting it. It will never be the closest gator to the boat for performance. I feel like this is an extension of our Florida man talk from last stream. I love that. I've never seen that before. That's an excellent way of putting it. It's in October. Yeah. And October is a bit of a month for me usually. So we'll see. I guess that would be... what would that be? Oh, the 4th through the 7th. It might be doable. We'll see. Yeah, again, it depends on where the engine is. That is a Florida man saying. Yeah, I feel like it really is. Let's see. Is the array index encoded into the 64-bit ID, or is it a separate value? It's a separate value. I mean, I suppose we could modify it to not be, right? But for now, it's a separate value. Because I feel like if you were to encode it instead of it being just a straight lookup, right? That's another level of processing that you would have to do. So it's like you're exchanging memory for that, right? You're saving a little bit of memory by doing that, but like at the same time, is it worth it? Because now you have more processing to do. So for right now, I'm just keeping it separate. Oh, I missed an ad break. Whoopsie. All right, so the timer there says 1.5 minutes, but it's really like 30 seconds. The benefit of handles is to avoid chasing pointers around in RAM. Yep. Data locality. Yep. Because the handle is literally just an index into an array. And you also have built-in checking to see if it's, legit. All right, I'm going to cut that off. Ads are dead. All right, so let's see. What even were we doing? I lost contract. No, I lost track of what we were doing here. Okay, 7:45. Did I not save this? Because why is it bleating at that level? Oh, I'm in the wrong dang file. That's why. I need texture system. Okay, so this, I think we already converted everything we need here. So I think we can actually get rid of this guy. And then we destroy the old texture, which I can actually grab that as well from this. Right. Let's see, where was that? Here. Right. And then I realized I don't need to do that anymore. And we free the data block. Okay. So that should be fine. All right, so we have a few less errors. 1007 is the next one. And that's another render target destroy, or render texture destroy. So I'm actually just going to grab this guy. And this is destroy texture. So this should just be a matter of using the internal handle. And then we don't want to zero the memory of the name. We actually need to deallocate that. So I'm going to do, we did a string duplicate on that. So I'm going to do a string free on that t name. Get rid of that. Then we zero the memory. I guess that's fine. And this ID of it eventually is going to go away. So I'm not going to worry about that either. Okay. So there's that. All right. 1034 undeclared identifier name. All right, so name. So this is going to be create texture. I guess, oh, we probably just use texture name here. All right. 1057. All right, create and upload texture. Oh, this is the same thing. Why was I thinking we had... All right, so we have image size. This is for the pixels array. So if we're doing a cube map, this is going to be... I guess we would have calculated that size in here. So I'll just do it in line. T width times T height times T channel count times 6. Right? 1057 result unused variable. Right. Okay. I don't think. Oh, we do a check on that. Okay. So at this point, we do have a result there. Do we have? I suppose we should probably put a result up here. And I'm going to default that to false. And do, I guess we could do return. Return false there is fine. If we don't do this, then we're going to say result equals true for that one. For the cube map, we'll just set result here. Okay, this guy will say result equals true here. And then down here, we will return result. Right, and I guess, you know, with all these return falses and stuff, we could handle that a little bit differently, but I think it's fine to short circuit there. Anyone know where to find this shader C CPP file? Mine isn't in the Vulkan directory, only headers. Do they supply that? I guess they'd have to, right? Let me see. Let me look really quickly. I'm not sure. I would have thought it would have been included in there, but I guess it's not. Let's see. Okay, so you're mapping IDs to array indexes. Yeah, so the handle ID is inside the handle is literally something called the index, and that's an index into the resource array for whatever it is, textures, meshes, whatever. I don't know what's going on, but we're talking about the ID that represents for each model's an index for the corresponding data. Yeah. So if we take a look at right, so our textures, for example, right now, our texture structure has a handle to a internal render texture resource, right? Which is like a Vulkan image slash Vulkan memory slash Vulkan view of that, right? And that is a K handle. So if we go to definition on a K handle, all a K handle is a small struct, and it has a handle index, right? So this is a index into some sort of resource table or array, right? And a handle is considered null or invalid if we set that to invalid ID. Now, invalid ID is just a define that we set up that is max uint32, right? And then we have this identifier structure, which, if we go to definition on that, is nothing but a single U64 with a unique ID. And I set this up this way just to be able to include additional like debug data if I want to be able to at some point. So a handle is just those two things, right? A globally unique identifier, which in this case is just a number that's globally unique, and then a handle index. And so when you say handle index, that's a index into whatever that system's array is. So it could be an index into an array of textures or an index into an array of meshes or whatever. And then that system would also hold on to a copy of this unique ID. So that way, when that system says, hey, free this texture, for example, it's going to set that unique ID associated with that index. It'll set it internally to like invalid ID or something like that. And then if we were to use a handle that still had that previous unique ID and index out there, we would look at that and say, okay, well, we have something at this index, but its unique ID does not match what we have. So it's a stale handle, and we're not going to give it to you, essentially. Okay. I have my IDs as a union of a character array and one or two 64-bit values. So the ID can be a text string, but referenced as 64-bit values for fast string compares, etc. Well, that's not a bad idea. Oh, thank you. Speaking of my awesome wife, she just brought me cobbler, which I'm sure is going to be delicious. Just got fired from my job of 11 years. Oh, dude, I'm sorry to hear that. That's terrible. Like, did that literally just happen? At least you can work now on your engine. I mean, silver lining is, I guess, but that sucks. I'm sorry to hear that, man. I recently went through a layoff situation myself, so I understand kind of where you're coming from. I'm sorry to hear you got fired, dude. That sucks. That's terrible. Night Rituals. How's it going? I appreciate the kind words there. All right. Is that the same as Vulkan using VK handles? Yeah, kind of. Like, I think what Vulkan does, like with a lot of their handles, though, is their handle is technically still a pointer. It's just like it's an opaque type, right? So it's like a forward declared, hey, we're going to have a structure that's called this, but we're not going to expose that outside of the source code, right? So an example of that would be, why won't this window close? Come on now. There we go. So an example of that would be in the platform H, we have, let's see, where is it? We have this platform state structure, right? And this varies per platform, right? So this platform state, this actual struct, does not exist outside of the C file, right? So if we go to platform Linux, for example, we go down here, we can see that we have our platform state with all of our Linux specific stuff, and our Windows specific stuff also type defs a platform state, right? But only one of these compiles at a time, because at the top we have this, right? So that's essentially what that is. You pity the poor soul that has to comb through your 11-year-old code base that nobody has touched but you. Insert evil laugh. I get that. Yeah, I had similar situations at previous places too, where, you know, I left and I was less like, if you guys need me to transfer the knowledge, you might want to do that before I leave. And then they didn't. Then I get a call later on, hey, can you help us out with this? And it's like, yeah, sure, for a fee. Yes, I also use the ID index all the time for models, unless some type of meshes, like a frame buffer, quad, or cube map, which is no need to be in that ID space. Yeah, so exactly. Yeah, I mean, you just, you only set up handles for things that you really need to have handles that you have a lot of, right? Serves them right. Yeah, exactly. Exactly. All right. Can alert you got fired recently from your 14-year employment. Man, I'm sorry to hear that. It's going around everywhere, isn't it? That's super rough. I'm sorry to hear that. Hope you land on your feet soon. Okay. Let's see. So we got that done. I don't think just down to one. So we have our old internal data being referenced, which no longer exists. So that's texture system C1157. All right, so this is process texture reference. So for reference, lack of a better term, what this is doing, let me just verify something really quickly here. Actually, why are we setting that to 0 here? So what this process texture reference does is it takes we have an internal lookup table by texture name. And that's so that we can say, hey, give me the texture that's named this, right? Which is different from a handle. That's something we'd only want to look up like when we're loading something, for example. And the way that this works is we've got an internal hash table that we've, our own internal hash table. And that contains a list of registered textures that are that have the key the name as the key, right? And so what this essentially does is it says, okay, first let's try to look for a texture of this name, right? And if we have that, then let's say, okay, well, are we incrementing or decrementing the reference, right? Are we acquiring a reference to this texture, or are we releasing it, right? So this can be positive or negative, right? It's usually either a 1 or a -1, right? So -1 basically means that we're releasing a reference to it. +1 means that we're acquiring a reference to it. And the idea is that whenever we acquire a texture that hasn't been loaded yet, we'll go ahead and load it and then say we have a reference count of 1. So let's say something else comes along and says, okay, I need a handle to this texture as well. Now we have a reference counter of 2, right? Now let's say both things release their references to that texture. That means its reference counter will equal 0. When we initially acquire the texture, we can say whether or not we want to auto-release the texture. If auto-release is set to true and that reference counter hits 0, it actually automatically unloads that texture for us so that we don't have to do it, right? So all we have to do is ever acquire and release texture references in that manner. And then there's some other details in here that don't necessarily go into that warrant a full explanation because we've already done videos on this, right? But that's the basic gist of what's happening here. And so what this is doing is I just need to follow this through. So this is the hash table get, which if that's successful, that means we did find an entry, right? And that includes all of this code. And so that means we have acquired it. or at least we found something. Let's see. If reference diff, that means release. So we're not releasing it, so we must be incrementing. And this is done where the reference handle is invalid ID, which means no texture exists. We're standing up a new one. So we loop through our internal registered textures array, which is where our handle will be referencing. And then we either find a slot or not, which we actually need to refactor this a little bit because we shouldn't fail on this. We should probably just insert a new one, right? But I think we only allocate this when we stand the system up, so that's going to require a little bit more work. But for this case, we'll say we found a texture slot. And now what we're actually doing is we are filling out that. So with that in mind, we don't need that. We can get rid of it. We also have to do, though, instead of a string end copy, we change this from being an array to a character pointer, right? So we need to do a string duplicate for name. Right? And that should solve that problem. So if we build again, get a lot farther, right? So you will have seen there's a bunch of warning messages up here, and that's fine. That's because there are some APIs that are with, or some render API functions that we're actually deprecating. And I've chosen to throw warnings about those so that we don't forget to do them. It's just going to hassle us about it until we do it. And remove them, which I'm fine with. So it looks like it was able to build all that. So the shadow map pass is next on the list. Max Conrad, thank you for the follow. Appreciate that. Not sure if your material and texture objects should go into a D array or a hash map. Or is there a rule of thumb? I say both. And here's what I mean by that. So the way that we use a hash map in our texture system and pretty much everywhere throughout the engine is our hash map has a string for a key and an integer for its value. That integer is an index into an array, right? So we actually keep all of the resources in an index or in a D array, right? So that means that our hash table can store an entry, right, into that array. But then we can also have our handle system also store an index into that array. So now we have two ways of looking up the texture. We can say, okay, we can get it by name, which of course is going to be slower, right? But maybe it's the first time you do it, right? And we could say, okay, get this texture by name. And then maybe it creates a handle and says, here's a handle to that texture. Or if you already have a handle to it, you could say, give me the texture for this, right? Yeah, so it's because it's all an array already, and our hash table is really just a reference to that, and our handles are really just a reference to that. It lines up beautifully. It just works. In my case, each model only has one texture, so the texture ID usually matches up to the object ID. Combine PBR multi-textures into one texture so that an object can have many materials but bind once. Yeah, and we've actually we combined in our PBR pipeline. We combined the roughness, metallic, and AO maps, right? Because each of those only require one channel of data. So we stored one on the red channel, one on the blue channel, one on the green channel. And yeah, we were able to save a lot of texture memory that way, for sure. And right now it's a pre-processing thing that you have to do, but we actually have a utility that will do that for you, right? So you can generate, your artist can generate the maps separately, and then you basically just configure this command line tool that we have to say, okay, take these 3 textures and combine them into one, and it just does it. So yeah, it works pretty well, I think. All right. So shadow map pass, frame count. Ooh, okay. So this is part of what we were talking about earlier in the stream. That is what, 559. Okay, so let me close this guy. So this is part of what we were talking about that we needed to get rid of from the rest of the engine, right? So there is no reason that the shadow map pass should know or care about how many window attachments we have. And window attachments means essentially number of frames we have, right? So for triple buffering, we'd have 3, for example. It shouldn't care about that, right? It should only ever care about the fact, like, hey, we have this window attachment that goes with this frame buffer, and then the internal renderer, the Vulkan renderer, can say, okay, well, we know that we have this concept of triple buffering, and that we actually have 3 textures that back this one texture. But like the rest of the engine shouldn't have to care about that, right? And that's part of what we're actually refactoring this for, is to get rid of this kind of crap, right? Because you have attachment count here. And then for each of the cascades, you have to loop through the targets for each frame, right? And then do something with them, right? And that's crap. We don't want to have to do that. We only really want to have to do this once, right? So like this whole loop should not even be a loop, right? It should just be a single target, and then we're done. So yeah, that's more or less why we're doing this huge refactor, is to get rid of this kind of crap. Sounds like a good ID system. Do you have to make sure that there are no hash map collisions to avoid 2 or more resource names from pointing to the same index? So that is something I'm eventually going to have to address, and it's something I've actually run into a couple of times before. But that's just implementing a good hashing algorithm, right? Which the one I have now completely sucks. It's about as basic as you can get. So I am eventually going to have to step up the hashing algorithm for that, so that we don't have collisions. But for right now, I pretty much know how to get around it, right? But yeah, it is something we're going to have to address, because that's the only part of it that kind of sucks. The disadvantage of writing our own hash map, right? Let's see. Is there a benefit of triple buffering over just double buffering? Frame ready for sync, pretty much. Yeah, I mean, it's basically you can make sure that your GPU is being used to its full potential, right? So you're able to generate more frames at once. You can have more frames in flight at the same time. And so what that means is you can be, while you're displaying one frame, you can technically be generating the next 2, right? Which means you can get them out quicker, essentially. So yeah, kind of the default for most devices in Vulkan is triple buffering. Higher frame rate is the benefit, essentially. Of course, if you have VSync on, it doesn't matter anyways. But also it can, help to reduce input lag, stuff like that. So, let's see. How long have you been programming for? You're a Vimmer, so I assume 10 plus years. Yeah, you'd be right about that. So the irony is, though, that I only switched to Vim about 2, maybe 3 years ago at this point. I used to use regular Vim. Now I'm using NeoVim, right? But I've been programming. I technically started learning how to code when I was about 7, using MS-DOS QBasic, if anybody remembers that. Aging myself there. But yeah, that puts me right at about, give or take, 30 years. But yeah, it's been a bit. But yeah, the Vim aspect of it is fairly recent. There's also an argument for frame blending and various layer stuff. Yes. There's also, it gets a little bit tricky too when you're talking about VR and when you're talking about ads, because we have ads. So we're going to break for 90 seconds. We have about a minute left. Almost done with ads, then we can continue. About 20 more seconds on ads, and then we are good to go. All right. Ads are dead. We are back. So just as a reminder, I like to pause the stream whenever ads are served on Twitch, which is once every 30 minutes for up to 90 seconds. So just do that so that nobody misses any content, right? Okay, so in this case, there are a couple things that we have to do. So this shadow map pass destroy is actually pretty easy because it's just destruction. This render interface point here doesn't exist anymore. So this is basically to get that window attachment count for how many frames we have. We don't have that anymore, so that goes bye-bye. With it goes this loop, right? So we just have one of these now. And targets per frame doesn't exist, right? So really we're just dealing with this particular cascades target, right? And so now we can say cascade targets, right? Let's just go ahead and say 0 on that for right now. And if we take a look at this, we have one target per frame under cascade resources, right? So this is no longer correct, right? This is really a single render target, right? So all we have here is no longer an array. We just have cascade target. Which means, let's see, we don't have to do this free operation anymore. And technically we could just say render target destroy. We can just say the address of cascade target, right? And get rid of that. So that's a lot simpler, obviously. Let's see, render texture destroy. So we also have to destroy depth textures, right? And this is another thing that, like, we have one depth texture in our shadow pass per frame, right? But it's not up to the shadow map pass to be aware of that. So we're gonna do the same thing here, and instead of attachment count, right, we're just gonna remove that, and we're gonna remove. We have this depth textures array here. This is just going to be a texture, which is just depth texture, right? A singular one, right? And so we don't need to worry about that anymore. That can go away, and this just becomes depth texture, right? Okay, so that is it for that. Populate is going to be probably another issue. Let's see. C-shape, no. That's my answer there. No. Let's see. I'm not yet having a system for duplicated objects yet. If two objects shares the same file, it's no longer true. I ported the API to DLL scripting, and I'm able to do scripting stuff using external DLL. Nice. Yeah, it sounds like you're making pretty good progress then. Yeah, duplicate objects can get a little bit weird. If two objects shares the same file, that can get a little bit weird if you don't handle it correctly. For sure. That's one of the reasons that we have things like, a texture lookup system or a texture registry, right? Is to avoid that issue. Because if we simply request that texture again, which ultimately points to a file name, but we do it by name, right? So the way our texture system works is we say, hey, we want a texture with this name, and that name ultimately gets a couple of different file extensions tacked onto it, like PNG, Targa, whatever. And the file system searches for one of those until it finds one, right? And then it loads up that texture and then hands it back. And so if you do that more than once, it's going to say, hey, this texture is already loaded and in memory. Just have another reference to it, and then you don't have to worry about it, right? Okay, so shadow map pass source populate. So this has got frame count again, which we don't do, right? So source textures, that should be like source texture, which I think this is actually a list of pointers, I believe. Pete's Astrophotography, thank you for joining the YouTube memberships and the supporter role. I appreciate that. I appreciate that support very much. Thank you. Means a lot. Appreciate it. Let's see, go to definition on this guy. So render ref pass. Let's take a look at these sources. So we have a name, type, origin. Render targets. I thought it was, did we remove? Render graph source. Source textures. So we must have already removed the textures list from here and just not refactored this. I know we did the render graph stuff I think last week. So I'm pretty sure that this is supposed to just be a single texture, right? And I thought, you know what? Let me undo this. Thank you for the follow over on the Twitch side, by the way. Appreciate that. I'm gonna do a fix me because we're starting to run low on time left for tonight. Should just be. Actually, you know what? Let me undo all of this, and I'm just gonna note the whole thing here. Fix me should just be single frame. Actually, let's just say frame agnostic. Single source texture. So we're going to have to rework that in our render graph source, because our render graph source doesn't seem to contain that data, and I'm not sure what we did with that off the top of my head. So we've got to relook that up. Because I thought we could just retrieve that from the actual render graph source itself, but it looks like we got rid of that. So that is why this is broken. So if we do regenerate render targets, aha, womp womp. So we didn't fix this yet. I think this is where I left off before we started doing all the texture rework stuff. This and all the PFNs related to it can likely be removed completely. Okay. So this is what this is actually what we were going to circle back to. I remember this now. It's been a while since we actually looked at this, right? So all that texture work and all that renderer work that we just did was all to support this. That's how we got off on that tangent. Because what this was doing before was literally going through and like getting a render target to count and like performing all of this logic to set that stuff up. And now I'm thinking that it shouldn't be doing any of that. So if the render pass has targets it owns, it will also be aware of when those need regenerating, which makes sense, and won't need a call like this to facilitate it. And then in terms of getting textures that are owned outside of it, right? So if we have like render target attachment source default, we should be able to say, hey, renderer, give us the render target attachment for this window, whatever window we're rendering to, and get them that way. Let's see. What method do you use for multi-light shading? Is it deferred or direct or something? I don't have multiple multi-lights implemented in the shader yet. So right now we have a forward renderer. And that's one of 3 systems, at least for now, that we're going to implement, right? And so we have a forward render graph, right? Which is what sort of uses that, right? We're also going to have a deferred render graph that's specific to deferred lighting. And then we're also going to have a forward plus render graph, right? And so the idea of having these render graphs set up differently is that the application could say, hey, I want to use this lighting model, or I want to use this lighting model, or I want to use this one. And just enter in some config and then roll with it, right? Forward plus is all the rage. Yeah, exactly. Forward plus is probably the one we're going to use more often than not, but at least for this first game, we're probably just going to use forward, to be completely honest. So yeah, we are going to be implementing forward plus on here at some point. Probably not before the first game, but probably before the second game. Especially if we want to do like a lot of complicated things with lights. Like right now we have a theoretical maximum of 10 lights in a scene that can be active at once, 10 point lights, right? And that's just something that I hard-coded in for the forward system. Eventually, we're probably going to take that limitation out of the scene and just apply it in the renderer and say, hey, the renderer will only render maybe the 10 closest dynamic lights if there's more, right? And just figure it out that way. Whereas, you know, forward plus won't need to do that, for example. You can even mix them in a single frame. Forward for UI wireframe and deferred for lit geometry. Yeah. So actually for our deferred pipeline, it actually is going to be a mixture of forward and deferred, because all opaque geometry will be forward rendered, all transparent geometry will have to be forward rendered. Just because of transparency sorting, right? So yeah, that's a thing too. All right. So yes, we have, in fact, I think all that stuff is actually, I believe, yeah, we have all of that stuff here, right? We have deferred rendering and forward plus rendering on the to-do list, right? So yeah, our render graph definitely needs some enhancements. Some of that we're doing now, but we are going to be handling some of this stuff. Excuse me. We are going to be handling some of this stuff. I think deferred rendering is probably the next one we're going to do, right? Because deferred rendering kind of depends on forward rendering exists because you have to combine these two. And then forward rendering, or forward plus rendering, rather, kind of in a way, relies on deferred rendering to exist. And then it kind of builds on top of that. So that's kind of the order we're going to do those in. But yeah, we are gonna mix and match them, right? So when I say like we're using a forward renderer or we're using a deferred renderer, technically the deferred renderer is going to use both of these. If you have forward plus, you don't need deferred because it will waste your time encoding. That is true, but remember this is a educational exercise, right? So we're going to go through it anyway as a learning exercise, right? Because it's going to be sort of a step towards forward plus rendering, right? Because like I said, forward plus will use a lot of the logic that deferred actually gives us. So it's not a complete waste of time. It's like we're building it up in blocks, right? And also forward plus requires compute shader support, which we don't actually have, at least on the front end. So there's that too. But yeah, it's not a complete waste of time. We're just going to keep building it up in steps, right? All right. So we have about 8 minutes left until I generally end, but I don't think I'm going to get a whole lot actually accomplished in 8 minutes. So I think what I'm going to do instead is I'm going to put a pin in this here. And let's see. Let me make a new session. And I'm going to add all of the stuff that we've done. Status, right? Which is, incidentally, a whole crap ton of stuff that we've actually changed, right? So I'm gonna go ahead and push what we have up to this reorg branch. Commits. If I could spell. So work in progress. Actually, texture system refactor. Actually, it's actually both texture render system refactor for internal data. And then we flattened out the Vulkan plugins hierarchy structure, like the file structure. We flattened that out, so that's what a lot of that is. Work in progress. Render graph. Refactor for single texture targets. All right, and we'll just push this because I'm long overdue for pushing that to the repo. All right, so with all of that said, let's find somebody to raid because I think I'm going to call it for tonight. I'm kind of tired, to be completely honest. Before I do that, if you guys have any questions, feel free to chuck them into chat, and I will read them before we close down. I I forgot, is a render target similar to OpenGL frame buffer. So a render target in our case, it contains a frame buffer, right? So we have a Vulkan frame buffer, which is similar in concept to OpenGL's frame buffer, right? So our render target is a combination of the frame buffer and the texture or textures that frame buffer is linked to, right? So that may be a color buffer and or a depth buffer and or a stencil buffer, right? So that is essentially what a render target is. When we say render target, it's just the grouping of those things. Yeah, no problem, RCW. It's good to see you here. Let's see. All right, so let's see who we can raid. Just gonna have a look through the list here. I want to look for somebody that hopefully has like an actual programming stream up. Let's see. I should probably categorize my search. Yeah, let me do that. All right, so let's see. Doesn't look like there's a lot of game dev specifically. At least not programming streams. It's probably because of the oddball time, right? Okay. I think what we might do is I haven't raided this channel in quite a while. I'm going to raid Ferret Software because I think it's a really good cause. It's basically a ferret rescue that is run by the ad revenue of the channel. So simply having the stream open is enough to pay for the all of the efforts that go into caring for these ferrets. I think they've got like 22 or 23 of them at the moment who have all been rescued from near-death situations. Some of who have required really expensive surgeries and medical care to actually rehabilitate them. And they're not an easy animal to care for, and they're given a good home, and it's a permanent home. And I think this is a really good cause. I like to support it whenever I can. So that is who I'm going to support tonight. And on the YouTube side, I will drop a link for you guys just in a second if you are interested in that. But yeah, that is who we're going to raid tonight. So thank you guys so much for being here. I really appreciate you guys. If you haven't already, follow me over on the Twitch and or YouTube side. I greatly appreciate the follows. It helps me out a lot. And we'll see you guys in the next raid. The next stream. All right. See you guys. All right. And for you folks over on the YouTube side, let me just drop this link for you, just in case you guys are interested in that. All right. See you guys.